Hello, I will be doing my video 1 on the limit comparison test. So let me share my screen and get my presentation started. So here's a limit comparison test by me, Anthony Duong. So when talking about the limit comparison test, we first want to just put down two infinite series. So the first one being the sum of n equals k to infinity of a sub n, and the second being the sum of n equals k to infinity of b sub n. So a sub n is greater or equal to 0, and b sub n is greater than 0 for all k values that are equal to 1, or k plus 1, k plus 2, plus 3, and so on. And then this is a rule for the limit comparison test. So if the limit as n goes to infinity of a sub n over b sub n is positive and does not converge to 0, then both infinite series a sub n and b sub n either converge or diverge. So this really helps because you know that like it either goes converge or diverge. There's no other real option. So let's do an example here. So determining whether this series converges or diverges. So we have the sum of n equals 1 to infinity of 3 to the power of n over 4 plus 4 to the power of n. Since 4 is just a constant, we can turn that into 3 to the power of n over 4 to the power of n, which is just 3 over 4 to the power of n for all n values greater or equal to 1. So with this setup, we now take into consideration the geometric series, which is the sum of n equals 1 to infinity of ar to the power of n minus 1 is equal to a plus ar squared, and so on. So if the absolute value of r is less than 1, it is convergent, and if the absolute value of r is greater than or equal to 1, it is divergent. In this case, our absolute value of r is 3 over 4, and it is less than 1, so the series converges. And as seen below, a sub n is less than b sub n for all n, so then a of n is also convergent. Let's do one more example here. So we have the sum of n equals 1 to infinity of 5 to the power of n plus 1 over 4 to the power of n minus 7. To convert this into something that we know it is 5 times 5 to the power of n over 4 to the power of n minus 7, which then turns into, which is greater if we take out the constant of 7, 5 times 5 to the power of n over 4 to the power of n. Then as we move the 5 to the front, we just have 5 times 5 over 4 to the power of n for all n greater or equal to 1. As far as the summation here, we can put the 5 to the front. So we have 5, the sum of n equals 1 to infinity of 5 over 4 to the power of n. And as we just saw with our geometric series, the absolute value of r in this case is 5 over 4, which is greater than 1. So it diverges. So this was my presentation and video on the limit comparison test. And thank you so much.